Every time you step onto a cruise terminal, the same image hits you. A wall of white, gleaming, blinding. Most people assume it's branding, luxury, status, but that's not it. The real reason is buried in physics. It runs directly through fuel bills, engine loads, and a decision made long before air conditioning existed. The answer changes how you look at every ship you'll ever see. Go back 100 years. The Titanic was black, so was the Lusitania, so was almost every major ocean liner crossing the North Atlantic. The reason was simple: coal. Loading coal in 1910 was not clean. Dust poured down the sides of the hull. It stained everything. A white ship would look filthy within hours of refuelling, so lines painted their hulls black, not for style, but to hide the mess. The superstructure stayed white. It sat well above the coaling ports. Coal dust never reached it. Two-tone. Dark below, white above. That's where the look came from. Not a design choice. A maintenance solution. The ships that look most glamorous in old photographs were dressed that way because coal is dirty. Then fuel oil replaced coal. The mess disappeared. Ship designers had a choice, and that choice turned out to be one of the most consequential in maritime history. To understand what happened next, you need to think about what colour actually is. Remember the prism experiment from school? A prism splits white light. Red is at one end, violet is at the other. Each colour is a different wavelength. Red sits around 700 nanometers. Violet is closer to 400 nanometers. When you see a colour, you are seeing the wavelength that object reflects back at you. A red hull reflects red wavelengths. It absorbs everything else. A black hull absorbs all of them. Nothing bounces back. The object takes the energy in. Hold that thought. A white hull reflects all wavelengths. Every single one bounces away. Nothing gets in. That's not poetry. That's physics. Visible light is one part of the electromagnetic spectrum. Electromagnetic waves carry energy. The microwave in your kitchen heats food the same way. Different wavelength, same principle. Sunlight hitting a hull isn't just light, it's energy, heat, delivered continuously, all day, every day at sea. A dark hull absorbs that energy. It converts it into heat inside the structure. The steel warms up, the rooms warm up, the air inside warms up. A white hull bounces that energy away before it ever enters the ship. That's the entire game. That's not a small difference when you look at the scale. A cruise ship hull can span 300 meters. It rises 20 decks. It's one of the largest continuous surfaces exposed to direct equatorial sunlight in the world. The Caribbean, the Mediterranean, the Gulf. These are the routes cruise ships run. Hot climates, intense sun. Reflected off water too, the ocean doubles the exposure. Every square metre that absorbs instead of reflects adds heat to the interior. Multiply that across a ship the size of a city block. That heat has to go somewhere. It goes into the air conditioning system. That's where the real cost lives. On a cruise ship, HVAC, heating, ventilation and air conditioning accounts for more than 30% of the total power generated on board. 1/3 of every litre of fuel is used just to keep passengers comfortable. Oasis-class ships from Royal Caribbean have 18 decks and carry more than 6,000 passengers. The energy demand from cooling alone is one of the most closely managed numbers in the entire operation. These are not abstract figures. Fuel is one of the largest operating costs a cruise line has. It shapes ticket pricing, route planning and scheduling. Anything that reduces the cooling load reduces the bill. A white hull reduces the cooling load. That is the connection. Think about what that means in practice. A ship that runs cooler needs less cooling power. Less cooling power means smaller HVAC output. Smaller output means lower fuel consumption per hour at sea. Over a year-round operating schedule, those hours stack into serious money. The hull is also not the only surface at play. Portholes, deck surfaces, funnels, all of it sits in direct sun. White across the entire vessel creates a compound effect. Every surface that reflects instead of absorbs contributes to a cooler ship. The math adds up quickly. A darker hull is not just warmer looking, it is warmer hull, hotter interior. The air conditioning works harder, more fuel burns, more cost. Every voyage, every season, every year the ship operates, a ship running 300 days a year in the Caribbean is making that calculation constantly. White paint is not a style choice, it is a thermal management decision. It has a direct line to the balance sheet. Not all white paint is equal. Standard commercial white reflects 80 to 90% of sunlight. That is already significant. Researchers at Purdue University pushed further. Their formulation uses barium sulfate particles at varying sizes. It reflects 98.1% of incident sunlight. It set a Guinness World Record as the whitest paint ever made. In outdoor tests, it kept surfaces 4.4 degrees Celsius cooler than the surrounding air temperature at noon. Not cooler than a darker surface, but cooler than the ambient air itself. Cover 1,000 square feet with this paint and you get the cooling power of a standard household air conditioning unit. Without running the unit at all, cruise ships do not use that formulation yet. But the principle explains why a reefer ship, a refrigerated cargo vessel, is also white, not branding. Insulation logic, white fights heat. If you ever spot a white cargo ship, that is almost certainly the reason. It is keeping something cold. So why aren't all ships white? Because not every ship has the same problem. Cargo ships don't carry 6,000 cabins that need to hit 22 degrees. Crews are small, interior spaces are minimal. Operating economics run on cargo volume, not passenger comfort. Colour is essentially free for them. Red, blue, orange, green, whatever the owner wants. Some carriers use colour for brand recognition at ports. Others just pick what's cheapest. Heat load is not a meaningful factor in the decision. Passenger ships that choose non-white pay for it. Cunard and Holland, America, carry dark hulls because their history traces back to the North Atlantic. Cold water routes. Heat was never the problem there. The tradition stuck long after the routes changed. Their air conditioning costs are measurably higher as a result. Virgin Voyages chose grey and red, a deliberate aesthetic rebellion. They accepted the trade-off. Disney chose black hulls and gold trim, a direct callback to the ocean liner era. Titanic glamour as a selling point. Beautiful ships, more expensive to operate. The colour is a choice. The cost is not optional. White has always been doing more work than anyone gives it credit for. Commercial aircraft are white for the same reason. A bare aluminum fuselage in direct sun at altitude would cook the cabin without reflective paint. Buildings on the Greek islands have been white for centuries. Long before anyone understood wavelengths or electromagnetic radiation, people knew white surfaces stayed cooler. It was practical knowledge passed down through generations. The entire field of radiative cooling research, one of the fastest growing areas in materials science, is built on exactly this principle. Reflect the energy, don't absorb it. White isn't luxury, it isn't tradition, it isn't cleanliness. It's a solution to a thermodynamic problem that's been in plain sight for 100 years. Every time you look at a cruise ship and see that wall of white, you're looking at physics at work. The most expensive colour on the ocean is the one that doesn't reflect enough.